So as we have seen, Lean and Six Sigma, two different methodology has been joined together as a Lean Six Sigma methodology. So when we look into Lean Six Sigma methodology, the Lean part will be always focusing on identifying and reducing 8 waste in the process. 8 waste, or the waste are defined as 8 type of waste is there. So we're trying to do a systematic approach to reduce or eliminate those activities that do not add value to the process. It can be a step which is creating defects in the process. So when rework is happening and because of a defect, no step is not creating any value to the customers or to the process. So incorrect informations are given or rework is happening in the process. So we call that as a defect. So easy to remember this 8 waste is downtime. So it is the first alphabet of each waste or muda. So muda is the Japanese term for the waste. So downtime is the uh, acronym or the first letter of all this 8 waste. So defect is any mistake resulting in a rework, or a scrap we call as a defect. Overproduction is producing more than that is needed or before it is needed. When we producing it in lean, it is called as overproduction. So when we waiting time is another waste, where we are wasting time waiting for the next step in the process, waiting for people, waiting for tools, waiting for inspection, waiting for inventory. So anything that is we are wasted time or idle time where we are not doing any work. So this called as a waiting in the process. Non-utilized potential is we call as the where when we are not utilizing a person's talent or a skill or knowledge in their full potential. We say a wrong person in the wrong place, or underutilization of people, we call as a non-utilized potential. Transport is unnecessary movement of product or materials are called as transportation waste. Inventory waste is excess products or materials not being processed is called as an inventory waste, more than what is required when we are storing it. It is called as an inventory waste. Unnecessary movement of people, even machines, are called as motion waste. Extra processing or over processing is unnecessary processing or activity that is a process that do not create and add values. Maybe no 2 3 people doing the same work or the same activity over and over again. So 2 or 3 people checking the same part again and again. It's an extra processing which is unnecessary to any process. So doing work more than what is required, or doing extra work which is not required in the process, is called as an extra processing, also called as an over processing. So this downtime is what we try to see in the unwanted activities. So we try to see, do we create any defect in the process? Overproduction and inventory, the difference is producing more than required is before it is required, and more than the customer's demand is called as in overproduction. Inventory is when we are not processing it, or when we are producing and when we are not storing it, or when we are not dispatching it, or any material which are not being processed. So when I say excess product, it would be work in progress. It is called as a work in progress. The inventory is between the steps, or one sub-assembly part is there between the steps. So we call as inventory, or work in progress is also called as an inventory waste. So when a product is not produced, but it is not dispatched, or it is not packed, so it is what we call as the waste in the processes. So our production is producing more than what is needed or before it is needed. Uh, Based on it is not based on a customer demand we are producing. It is a waste. Inventory is more than any material. It can be a raw material that we are looking into, or work in progress. When we look into more than one between the steps, we are seeing more of it. Inventory is being stored between the steps more than what is required, then it is an inventory waste. So these are different ways that we look into the process. So now let us look into Six Sigma. So similar to, because Six Sigma methodology is focusing more on systematic problem solving. In a systematic problem solving, we are trying to identify and reduce a process variation so that an optimized process output can be given to the customers. So we are trying to achieve the customer satisfaction or business excellence by a systematic problem solving in Six Sigma. So in problem solving, in a systematic problem solving, the Six Sigma approach focus on identifying and reducing process variations. So the Six Sigma is usually denoted as six as a number and sigma as a symbol, a Greek letter which is used. The sigma is a Greek letter being used. So we'll see what is this. So sigma is a Greek letter which is used to represent standard deviation of a population. So when we look into Six Sigma, the sigma as a Greek letter, if the name of the sigma is a Greek letter which is denoting or representing standard deviation of a population of data. When we say population of the data, let us say when I have 6 months of production time or 6 months of order fulfillment time or 6 months of dispatch time. So when I'm looking into a metric which is important for me, for our process, maybe it can be a time taken for fulfilling the order from the customers or time taken for resolving a complaint from the customer, or can be anything that we are metric that we are measuring from the process. So sigma is the letter that we used to represent standard deviation. So standard deviation is calculated by equations. So there are equations to calculate standard deviation. So when we have this equations are used, which I'll be taking to you later period. So when we look into this sigma as a measure, it is representing standard deviation of a population of data. We are looking into the spread of the data using sigma. So mu that you're seeing here is the average, or the average of a data is given by mu, or average is given as mu, or the mean of the data. Sigma is used for the standard deviation. So in Six Sigma, the sigma represents standard deviation of the data or the process, whereas it is measuring the variation of a process. So sigma represents variations, and the unit of measurement of variation is standard